welcome all. I want to talk about website search and using Elasticsearch in particular. And so let's go. What do we expect from website search? Or what are our users expecting? They're expecting to find results on a lot of results, looking in different fields. They want in some way to say most relevant results first, because if you are returning too much results, they just are going to throw them. And since we are building a search engine focusing on our site, we can also add things like categorization, filter by category. But I'm talking about category, but it can also be think, for example, at a weblog. So we may have author, tags, etc. So we can add these. Then, of course, users are going to make typos when they do the query. So they will going to say, hey, you should understand what I mean, because I'm a user. And so we want to withstand user typos. And that's maybe typos are not only in user queries, but can also be in our content. So if we can withstand user typos, we can also withstand typo in our contents. Things like synonyms can be useful, because I may be looking for home, but you have content for house, or maybe it's a company website. I changed the name of a product of mine, like from Elasticsearch to, I don't know, Spring Search. And users are going to use both terms to query, because someone used the old, someone used the new, and want to return both results. So I want to have this feature like synonyms. Finally, from infrastructure point of view, we may need a solution that can be scalable, fault tolerant, easy to deploy. So not something that I have to use a big 100 gigabyte of RAM server, but maybe more server. Server I'm going to fail, so I don't want to have downtime, etc. And of course, I don't want to spend a week just to bring up my cluster. So maybe something that can be run in some minutes will be a better solution. So how can we do set search in Plone? The integrated way is Zeta catalog. Is fully integrated in Plone. Actually, it is more for navigation, but we can use it also for search. It doesn't have advanced features like synonyms, so ranking is not so good, but it is there. And we will need it for navigation and other things, but maybe the search backend can be moved to something that has been built for searches. So if we look for something more, we may find Apache Solar. It is 15 years ago it has been released the first time, so it is a year from a lot of time, a lot of integration. It is based on the Java search library Apache Lucene, and so it takes this feature from it. So it gives better result ranking, advanced features. We have in the last releases of Apache Solar also some clustering support. That is Cloud Solar using Zookeeper. It's not so easy to install it, but we can do it. An alternative is Elasticsearch. That's what I'm going to talk today about. It is based again on Lucene, so basically the engine that is under the two products is the same. Features are comparable. Maybe Elasticsearch has something more. Maybe Elasticsearch is going faster with the release cycle. And the great advantage of Elasticsearch is that it has been built from the beginning in 2009-10 with the scalability in mind. So the first releases of Elasticsearch was already a clustering solution. I don't mean that I have to install a cluster. I can also install one small node, because maybe I have a small needs. But when my needs will grow, I can just scale out my installation. And well, last thing about this more than personal point of view, it has more JSON and less XML, but it's more a personal thing. So All of these solutions, both Solar and Elasticsearch, can be integrated in Plone. There is already some eggs available, and these are the names. And so you don't have to do much work to integrate it. So you may have already hear about Elasticsearch for logs. And this maybe is the one of the most used use case of Elasticsearch, using Elasticsearch, Logstash, Bits, Kibana. That is all a solution for managing time series data. But the same product, Elasticsearch, can also do searches, and it does it well. It has a different fine tuning, but it's the same. Also, Elasticsearch has been born for searches, so maybe logs has just a second use. So for your website search, you only need Elasticsearch. I would advise you to install also Kibana as a web interface management, but just a commodity. So Elasticsearch. Why are you using it? I would say it is distributed by design. It's very fast. You have a relevance ranking machine. All its interface is RESTful. You can integrate it with whatever solution you want. There are libraries for the most programming languages. Python is one of them, of course. And you talk at REST with JSON payloads. What if I want to index or suppose that I have a Elasticsearch class ready, I want to insert a new document. It's just a post or put call. So this, for example, in a new class, I don't have to define types, nothing. I just put a document, and Elasticsearch will just respond with yes, I indexed your document. Of course, maybe it will not be also optimized, but it's a good start. A date, if it is in the right format, will be interpreted as a date. A string is interpreted as with a double mapping. We see it in a moment. Because what are data types? That we have basic types like number, some more advanced type, we like IP, job point. Of course, when you have, for example, an IP, you can do query about IP, like subnet, or if you have job point, you can do queries about, and so give me all the documents that matches these that are inside this perimeter. Think, for example, if you're using websites for looking for an hotel or things like that. And keyword and text. These are for strings. What is the difference? Keyword is not analyzed string. So the string without any type of analysis, you can only match the entire string. So it's good for tags, names, and things like that. Text, it is for the content. So we are doing an analysis and to be able to query results inside the text. And so we have to fine-tune our mapping. This is called the mapping is the name of the types that we give to our indices for what we need. By default, if we not specify that, all string fields are indexed as both. So we can do both queries. And of course, more advanced types. So what I mean when they say that texts are analyzed strings? What we do, we take a text, we divide it in the tokens, and we can do some other things like stemming, like apply synonyms, and then we will index the results in an inverted index. And so when I'm doing a query, I will just look in the inverted index which documents will match that, we will have that term that I'm looking for. So analyzer, as I say, various steps. The most important, as I say, is the tokenizer and the stemming. The stemming is when you have, for example, verbs, you have a declination, you want to have the radix. So if someone looks, for example, for, I don't know, runs, but maybe you want to search run because it is just the declination. And of course, synonyms and so on. So we have a document, we can make a query. And this is a simple query. We search for a term and we will find results. As you can see here, we have the score because all documents are scored using the terms of the query. For example, this is a query with just one term, Elasticsearch. If you were looking for Plone and Elasticsearch, we will find first the documents that talks a lot about Plone and Elasticsearch, then documents that talks maybe about Plone and Elasticsearch, but also about something else, and then maybe documents that talks only about Plone or Elasticsearch. So we have both of them. They just have a different score. And so this is the score that we have of every document, of each document. And of course we can sort by other terms, like by date or by some other fields. It depends on what we need. Usually maybe we can give the user a selector to choose if he wants relevance or some other type of sorting. As I said, we want to withstand user typos, so we have fuzzy match, and that, for example, here I misspelled the Plone in the Plone, and it is going to match results. And so we can have different levels of fuzziness, and so we can decide how much we want to permit our users to do typos. Of course, we could also add a suggestion, like maybe you was looking for Plone. That will be another type of query. There are a lot, so I'm not going to show you all. Another type of query that I want to show is the multimatch, because now the scoring is coming back again, because in multimatch I'm matching my query across on different terms. And in this way, you will I also make a typo. Title at true, I'm saying if you find a match in the field title, treat it as double this importance. So a match is in title will be more important than a match in content, and so the score will be higher. And of course, we can also keep fuzziness. And much more. I already talked about suggestion. We have search as you type, jQuery, and so. Aggregation. You know, when we were talking about category, let's talk about, for example, author, we can show the most 10 author that matches the query. So let's say all the documents, and we can take the top 10 author, or maybe from, and this will return us the number of documents for each author. Or maybe for each author, we want to know what term he uses. So this is a sub-aggregation. We can put aggregation, or there are many things we can do. We can do metric aggregation, like I want to know each author, what is the average length of his post. Take, for example, the weblog. So again, all last published document, there are sub-aggregation very fast because they are done by the cluster and not by your front end. Much more, Judge Centroid and so on. Finally, how to run Elasticsearch. It's very easy. You download it. You untar it, you go in the directory, and you launch it. You can configure some parameter, but in a couple of minutes you have it up and running. You can also do the same for Kibana. There are images available for Docker, for Yum, apt, packages for Windows, Mac. So they are supported a lot. In production, maybe you want to install it with Yum. For developing, maybe the target data is now. Clustering. As I said, Elasticsearch has been built with a lot of clustering. Why? Because you need high availability, use 2 nodes. Replicas enabled by default. You need more space, you can just increase the number of nodes. And or maybe you need more performance because your search is it a lot. So increase the number of nodes and increase the number of replicas, so that searching, instead of eating only 2 servers, you can eat 2, 3, 4 servers. And with also hot and cold, you can use fast and slow disk. What's next? Elasticsearch app. It is the new interface, is Swift type, is all the name, so synonym. And it's going to help you in define how search is going to perform, like relevance, synonyms, all with a nice interface. It is not an already integrating Plone, but it's the next step. So to conclude, this is your homework if you want. This is the instruction to integrate Elasticsearch in your site. Just the first part is just to run Elasticsearch, and then you can add the egg and index your data in Elasticsearch and try it. So if you want, this is the way. I finish. I don't know if you have a question. If
Okay, coming.
I didn't understand the question. Maybe if I come here. See.
Sorry,
So
just
no,
a
but
second, because we can record your question.
Okay. So
Yeah, the question is basically, is the current version of Collective Elasticsearch ready for Plone 5.2 and Python 3?
actually, I don't really know because I read the documentation of Collective Elasticsearch, but not the version of Plone. I can say about version that if you see here, I talking about Elasticsearch 6 because that library gives compatibility with Elasticsearch 6. Now we are the version 7 of Elasticsearch. It has been it's come out in June, but I think that it is easy to switch from 6 to 7, but some coding is needed. So it is why I put 6. But Plone, I should check. I don't know.
Okay. Still a couple of minutes, so other question? Yeah.
I did also some work with Elasticsearch and Plone, but it was a different add-on we wrote. But the question is, how do you manage to do different types of queries? Can you configure them, like feed aggregations and so on? Or do you have to kind of drop-in index in this collective Elasticsearch? Or how does it integrate with querying? Or do you need to write your own view to query Elasticsearch?
Collective Elasticsearch should only do the indexing part. So then you will have to write your part of query, and so you should know a bit of the Elasticsearch query language. But it's not so hard, so you will have to just write how the fields will work.
Okay.
Actually, I haven't haven't tried it yet, so I don't know it.
There's a second add-on called collective.es.index that does it in a different way, but maybe you could also have a look at it. And we're at the moment in rewriting it a bit, but anyway.
Yeah.
And there's also a Plone 5.2 Python 3 branch.
Okay. I didn't find it with my search. Other question?
No question? Okay. Thank you.
Thank you.